Alright, so this is Unit 10, Lesson number 8, and this is the last lesson. We're going to look at the second type of electrochemical cell, which is called an electrolytic cell. And so let's just quickly run through this. If you remember back, we said that electrolytic cells involve non-spontaneous redox reactions. And since they are non-spontaneous, they don't happen on their own. So you actually have to have a supply of energy to force the reaction to occur. Usually that is going to be a battery. So again, and that's the process of how an alternator basically in a car works. It's used two things. It's used for electrolysis, which is when you take a compound that normally will not break apart on its own and you apply an electric current to it. It also is used in another type of electrolysis reaction, which is called electroplating. So if you take a look at the diagram that you see, I'm actually going to kind of quickly run through that. Before we do that, let's just quickly run through the cathode and the anode. If you remember, I said that you only need to know where the oxidation and the reduction occurs. You don't need to know which one. You don't need to know that it's negative, and you don't need to know that this is positive. But you do need to know this. Okay. So again, even though it's electrolytic cell, that the whole thing with the red cat and the anox still applies. Even though it's an electrolytic cell, reduction still occurs at the cathode. Oxidation still occurs at the anode. That has not changed. Let's go through the bottom. And this is the bottom. You're going to notice what they're doing is they're just going through and showing you what's the difference between the two types of cells. So you're kind of comparing them. So I guess we can. We're not going to worry about that. So let's fill this out quickly. Oops. Alright, so in a galvanic cell, the electrons are flowing spontaneously. This is non-spontaneous. We don't care about the positive or the negative electrode, but we are going to say that that red cat and ox applies to both. We don't care whether it's positive or negative. The electrons are always going to flow from the anode to the cathode in both. Okay. Reduction half cell, I'm not sure what they're asking you here. We're not going to worry about that. One of the things you should remember is that there is a salt bridge here. No salt bridge. This has two containers, and this has one container, and this requires a battery or a power source of some sort. Usually it's a battery. Alright, so that's kind of looking at comparing and contrasting the two types of cells. The galvanic or voltaic cell always has a salt bridge, always has two containers, involves a spontaneous redox reaction. Reduction occurs at the cathode, oxidation occurs at the anode, and that's the same for both cells. If you look at the electrolytic cell, there is no salt bridge. There's only one container. It involves a non-spontaneous redox reaction, and it requires a source of energy to keep it going to start it, because what happens is that since it's non-spontaneous, it's not going to just happen on its own. You have to actually force it to happen. In electrolytic cells, you can, for example, an example would be if you wanted to take water and break it apart. Now, water is a very stable compound. It's not going to split into hydrogen and oxygen on its own. You actually have to run an electric current through it. Okay? So if you look at it and you do the oxidation reduction, what's going to happen is that the hydrogen goes from a +1 to 0. That's going down. That's reduction. That would be the cathode. The oxygen goes from a -2 up to 0. That's oxidation. That would be the cathode. Okay, that's what you would do. Another example of that would be if you did, let me move down further so we can see this. If you wanted to do, like, for example, sodium chloride. if you wanted to break sodium chloride apart, split it apart, decompose it, it's a non-spontaneous reaction. Most decomposition reactions are. So if you want to split it into Na and chlorine, right? That's a plus 1, minus 1. It's not a balanced equation, but we're not going to worry about that. The sodium goes from plus 1 down to 0. That's okay. Oh, that got real big. So if you look at it, the sodium went from plus 1 to 0. That went down. That's reduction. That's the cathode. The chlorine went from minus 1 actually up to 0. That's oxidation. That's the cathode. Okay, and that's what you have to be able to do. Sorry about that. I'll try and figure out what's going on with that. The only other thing that you need to worry about is something called electroplating, which for some reason he doesn't show you in here. Electroplating is the second type of electrolytic cell. It's usually used in industry. And basically you've heard of things like plated jewelry, like gold or silver plated jewelry. Well, what happens is you'll notice that gold and silver plated jewelry is less expensive than real jewelry, and here's the reason why. When you get a piece of jewelry that's silver or gold plated, what they use to make the actual shape of the piece of jewelry is they use a cheaper piece of metal, and then through a process called electroplating, which is a type of electrolytic cell, they place a very thin coating of silver or gold on it so that it looks nicer. And that's a type of electrolytic cell. So for example, if this was an electrolytic cell, okay, let's say we had a ring, and it's a very bad example of a ring, and we wanted to put gold on it. Well, we can't just take this bar and rub it on the jewelry. It's not going to work that way. We have to do this through electrolytic process. So what we're trying to get to happen here is we're trying to get these gold ions, and I believe they're plus 3, to change into a gold atom and stick to that. In order for that to happen, the gold ions have to undergo reduction. So they would have to, they would have to gain 3 electrons. Okay, let's try that one more time. Okay, so the gold atoms would have to gain 3 electrons and become a gold atom and stick to the piece of jewelry. So and again, this would be the cathode. So the object that you are plating, the object plated is the cathode. The metal that you want to coat, the metal that you want to plate with is going to be the anode. So what's going to happen there is you're going to have silver atoms will be oxidized, okay, into silver ions, and they'll give up the electrons. And that's the process of electroplating. So what you need to remember is that even whether it's electrolytic cell or electroplating, or voltaic, the anode is where oxidation occurs, the cathode is where reduction occurs. What you also then need to remember is that when you're electroplating, the object that you want to have plated is where the cathode is going to be. The metal that you're going to use for the plating is where the anode is going to be. And that is pretty much it for